we are going to be talking about Derive macros, and this is a topic which I kind of recently got myself into because of a project I was working on. I'll get into a little bit more detail on that. The subtitle, of course, is How I Learned to Stop Worrying and Love the Proc Macro to TokenStream. So a little bit about me first. I'm Lowell. I'm a senior in cybersecurity at Western. Came down here from Bellingham, which is a bit of a drive. Um, and I like to develop software. I'm a little bit more of kind of developer minded person than a cybersecurity specific minded person. But right now I work in phone repair mostly and tablets and some other things. I've been working in Rust since about winter of 2022. But I have only been working with Derive macros since about this summer. So, if I have any information in here which anybody would like to clarify or correct, feel free to let me know because it might not be 100% accurate. This is mostly from my personal experience and my general understanding of this topic. A little bit about the presentation before we get into it as well. We're going to have a first part, which is where I describe what I'm actually going to be talking about and what information you're going to need to know before we actually get into implementing a macro. And then actually we're going to build a macro for the second part, if I can speak fast enough to get through the slides, of course. We'll see. In terms of like preparation, if you'd like to follow along, you don't have to. It's totally fine to just watch it, as long as it's not on that screen because it's broken. But I would just have VS Code ready or a browser. I'd recommend you have like some sort of Git Explorer. Git Lens is fine. Honestly, VS Code's integrated one is also fine. GitHub's probably the best option, and it's obviously the most portable because I set this up in a repository with all of the different steps that we're going to be taking. So this is going to be following a script that I wrote, which is a little bit more in depth. I posted that on that link on the Rust Discord, or not the Rust Discord, the Rust user group Discord. And you can follow it there. I would use like Obsidian or something to open the Markdown document, but you can also just read it in plain text if you like glaucoma or getting eye problems. So anyway, but I'm also totally open to questions. So if you have any questions, just raise your hand. I'll try to get to all of them. If there get to be too many, I might have to move on because it's a pretty long presentation and I have 40 minutes. So let's talk about what macros are. You guys might have heard of them before, especially if you have been working in Rust for a little while. One of the things that is mentioned first in the Rust book is that print line is not actually a function, but a macro. The exclamation mark kind of denotes that it's a macro. There's a lot of reasons why you would be using macros, but it's not particularly well explained, I guess, in the context of like beginner Rust literature, which is understandable. But it's the metaprogramming feature, which is essentially to say it's basically code generation or code that writes other code. There's a lot of things that you can do in the Rust type system, and it provides a lot of safety, but it also can provide some restrictions which may or may not be useful to your particular use case. And so when you need to go outside of the type system to do the operation you're trying to do, then macros are kind of your feature. There's two types of them. The first one is going to be declarative, and this is what you typically see, and it's probably the most likely, if you've implemented a macro, it's probably been a declarative macro. This is the one with the macro rules syntax. It's essentially just a regular expression, like it takes tokens and of different types and can interpolate them into some sort of code that you spit out. And there's not really any form of control flow other than a very basic kind of match statement, which it provides as a baked-in feature, where if you pass it a certain type of set of tokens, like 3 literals versus an expression in a literal or something like that, you're able to switch which version of the macro it uses. So those are relatively limited, but they are useful for things where you can't really just use a function necessarily because of maybe some really long dependency injections or anything like that. Now, procedural macros are the ones that are kind of the more complicated, I would say more complicated for sure. The syntax is maybe actually a little bit less obtuse than declarative macros, but they are also more difficult to set up. And they basically allow you to code gen through Rust code. So you basically will parse Rust syntax, or well, Rust will do that for you, and you turn it into essentially an AST, and then you can perform operations and spit out code based on what you have parsed. Yes. Um, an AST is an abstract syntax tree. I guess the question is, what is an AST? It's essentially a representation of the syntax of a language, so actually all of the code in a data structure format within the code. So you're basically working on Rust code as a data structure. Some really common macros, you'll see print line, format, which is kind of just print line without printing, and then derive, which is the procedural macro that we're going to be talking about today. And derive isn't actually a specific procedural macro, it's kind of a classification of procedural macro. So here's an example of a declarative macro. You'll see this macro rules syntax. It's kind of weird because you're using a macro to actually declare a macro. These are kind of unreadable generally, but basically what you're doing is you're creating a match statement, which you can see in the sort of way that it's structured like a match statement. If you've ever used Rust, it's kind of like a switch statement if you haven't. And in this one, I only have one variant. So I'm basically taking an identifier and a literal, and I'm printing out some sort of integer. It's assuming that the identifier you're passing in is the name of an integer. And then a padding value, which is how many zeros I want to add in front, or how long I want it to be. So how many zeros I want to add in front of it, depending on how long it is. So basically, it's using a couple of inner macros, printline and concatenate, to actually achieve a padding functionality. So if I were to write print padded 5 and then like 10, it would print 9 zeros and then a number 5. Yes. So at this point in the compilation cycle, you would have access to, I think, anything within scope, and that's for declarative macros only. So you can use any identifier which is in scope, which would include types, but you cannot bound the inputs to be specific types. You're not able to actually say, this input is going to be an identifier that refers to an integer. You can only say that it's an identifier, right? So the input can only operate over Rust syntax, whereas the actual functionality of it can reference types. So. Mhm. Yeah, yeah. So what she said for people online is basically if you have an external type in your macro, you're going to need to have users of your macro if you are exporting it, which is a whole extra process with this. If you are exporting it for people to use from a library, they actually have to depend on those types as well. So this is one of the problems with macros, is that it kind of obfuscates the dependencies and the errors that you're going to be getting behind a sort of expansion process, which occurs before, well, it occurs invisibly. You're not seeing it happen. There's a tool for seeing it happen called cargo expand, and we're going to be using that later. So procedural macros, like I mentioned before, are basically Rust code that writes Rust code. They're a lot more flexible, but they're also more complex to set up. Luckily, they're not super complex. It's mostly that the tooling is just janky. For for Rust standards, it's got really good tooling in general. Procedural macro tooling feels like it was kind of hacked on, and it really was. So, so until we get whatever macros 2.0 in 2057, we're we're going to be stuck using this, and we'll get into some of the more specific details of that soon. Basically, they're just either a transformer or an appender, essentially. So you have your code going in, that's the input of your macro, and then you have your code going out, which is either going to replace the code that went in, or it's going to add to it. A derive macro is a append version of this, and that's what we're going to be using today. Yeah, so it's written in Rust, but it's outside of the type system of the program which you are writing macros for. So you're not able to use your own types. You can use types within the context of the generation code. You're going to be using a lot of types like, TokenStream and TokenTree and Derive input and things like that. They also, as a system that operates using Rust code, allow for all of the things that Rust code allows you to do, like control flow and allocation. They also serve as the basis for a lot of popular crates. You'll know of probably this error, uses derive error, and it gives you a bunch of little helper attributes to make your, display implementation a little bit easier. Tokyo is, it heavily relies on the on like Tokyo main and some other things to actually work without you having to write a ton of boilerplate. Serde uses the derive serialize and derive deserialize, which makes it considerably easier to use than it would be otherwise. And then there's clap, which doesn't only use derives, but it does have a very popular derive API. They also have a builder API. Derive macros are, like I mentioned, type of procedural macro. So what type of procedural macro are derives? The answer is that a derive is basically a procedural macro that implements a trait on a type. Now, you might not know what a trait is if you're not super experienced with Rust, but if you have come from a programming background in general, you'll probably recognize traits as very similar to interfaces from like Java and C#. They're a little bit different in the way they work, but generally speaking, you can just assume that a trait is basically an interface. The idea of a trait is to provide shared functionality and describe similar objects, or whatever you want to call them, structures, so that you can use them generically. So there's going to be a couple of ways to provide shared functionality. And the other way to do this beyond derive macros is what's called provided implementations. The trait is going to have two parts. You have your signature, which declares like the name of the trait and any bounds that you give it. So anything that implements that trait also has to implement other traits that are related to it potentially. And then the body tells you what actually has to be implemented. So in Rust, there's basically three types of things you can have. You have functions, constants, and types. The most common is definitely going to be functions, obviously, but types and constants are still very important and very useful if you're doing more advanced trait, mucking about. There's kind of a system for provided or auto implementations. Any function or const or whatever that's in the trait, you can actually write a default implementation using functionality that's guaranteed to be there for all implementers. So that basically means, anything that's inherently implemented on the type. So if you have like a U32, you could use U32 max, which is a constant that says this is the maximum 32-bit unsigned integer. Or you could use, a rounding function on a float or something like that. That's what's called an inherent implementation, where it's not related to a trait. You can use it for trait implementations. So any function that's part of a trait. So if you have a trait bound or something like that, in your trait, then you can access anything that's part of that. You can also access your own trait members. So if you have maybe a const or something that's like a string, you can access that within a function in the same trait. And then these are usually called provided implementations, but they can also be called default implementations or auto implementations. And they can be overridden, which is kind of an important thing if you're working with these. It can also cause some complexity. So it's, use it with caution if you want people to be able to read your code. So here's a good example of a provided implementation. Basically, this is a trait called log. It allows you to, this is a very contrived example, but it would allow you to basically write a log to your console that says like something in a more basic format, and then write to a file something in a more verbose format. So that's using the display and debug traits that are built into the Rust standard library. So anything that implements both display and debug can implement log by just doing this, because if you look at the signature of log, the function log is auto implemented or provided for any trait implement, or for anybody who's implementing that trait generically, basically, because it's every single one of these types is going to be guaranteed to have the format, or the debug formatting and the display formatting. There's some drawbacks to this. As I kind of mentioned earlier, a lot of times it's very complex. You end up with like webs of dependent traits. If you want to see an example of this, I have my own project where I started using Derive macros, and you'll see a lot of like convoluted webs of traits and things that had to be there just to provide something for a provided implementation. They can sometimes break any sort of optimizations you would normally have on specific implementations, especially if you're using generics. Sometimes it's not possible to use them, and there's a lot of reasons for that. I have a couple listed here. If you have any variance at all between implementations, there's nothing you can do about it, because you can't react to the type itself that's implementing it and say, okay, if I'm implementing this on a struct, I'm going to have it work this way, or if I'm implementing it on an enum, I'm going to have it work this way. That's just not possible with these. There's also, anytime you want to work on Rust syntax outside of the type system again, you're not able to do that within Rust syntax in general, and not within a provided implementation. Anytime you need to use functionality that can't be guaranteed, like if you just know that every single struct that implements this trait has a field named ABC, and you want to do .abc in your provided implementation, but you just can't, because you can't guarantee that through the type system, you can use you cannot use provided implementations. So that's when you would kind of start working on using Derive macros. So Derive macros, like I said, it's a form of procedural macro that's used to generate a trait implementation. It doesn't actually have to implement a trait, which is kind of confusing. They can spit out arbitrary code. So you could implement 0 traits, or you could implement 500 traits. You probably don't want to do that, but you could. And I have used them in the past to generate inherent implementations rather than actual trait implementations. Usually, you're just going to have a Derive macro with the same name as the trait that it implements, and then you'll just put that on some struct, and it'll implement that trait for that type. They use the attribute syntax, which is a little hash symbol and then the square brackets, and they're put above a type signature. They're very commonly used, like I mentioned. There's third-party examples like serialize and deserialize. There's first-party examples you've probably used before. Derive debug is a really, really, really common one. You might also have used clone, partial EQ, partial ORD, and hash. So, it's very, very important because you don't want to have to be writing partial EQ implementations. Yes? Yeah, so the question is, does the Rust compiler care essentially about what is being spit out? Is it truly just arbitrary? And the answer is yes. It is just arbitrary. The compiler has no opinion about it. I have used it in particular to generate just kind of related structs with some metadata in them that are they have like a const constructor that I just couldn't do within the generic system. That type of stuff is definitely doable, and it doesn't give you any sort of warnings, and it doesn't give you any sort of errors about that. So it can be a way to trip yourself up if you kind of start using it more free form and without any sort of structure. So when you're using macros, try to let the type system help you a little bit, here's an example of a Derive macro being used. You have a type. This is what you call a type signature if you're not familiar with Rust. This is a really common concept in any language, but with types, not JavaScript, but you have your type declaration, struct my type, and then you have your fields inside of there. And Derive debug basically allows you to print it out in a sort of verbose way, I guess you could say. Some custom attributes you can, well, to I guess clarify a little bit. Custom attributes they use the attribute syntax just like Derive does, but they are custom or special. You have to design them yourself, and you have to parse them yourself. They're oftentimes used for third-party stuff. I'm not sure about this, but I have never run into a standard library Derive that uses custom attributes. But here's a good example, I guess, if you wanted to do a debug, if you had your own kind of third-party debug implementation, or let's say Derive macro, you could give it a special verbosity level, and it'd be like when you're doing SSH, and then you just put like 5 V's in front of it to figure out exactly what's going wrong, and you increase the amount of stuff that's being printed out. Maybe it's printing out the bit representation and the text representation or whatever, but that's providing extra metadata that can't be provided through the type system. Oh, I think isn't that in a trait extension library? Okay. Oh, I see what you mean. Yeah. So what he was saying was that the default macro or Derive.
A lot ahead of me.
Okay. The default Derive macro allows you to annotate a specific enum variant as the default variant. So let's get to implementing our own Derive macro. Now I didn't make slides for this. I'm going to be writing out the code in my editor. If it takes too long, I might just go through GitHub and start doing it that way. But we're going to be getting into VS Code at first here. And I'm going to have, I'm going to change my screen share, I guess. Let's see here, share window. All right. All right, don't look at this yet because you're not supposed to see how it's supposed to turn out. If I can get it to expand, there we go. All right, that might be a little too small. Here we go. All right, so I'm actually going to make a, yeah. Is that better? Okay. I'm gonna go, we'll do cargo new, how to Derive macros present CD. There we go. Okay. Okay. So what I would like everybody to do, I feel like I didn't display this slide for long enough, but I'm gonna switch my screen share back to the slides for one moment, and give everybody a chance to get their things set up if they want to. Again, it's totally optional. Okay, here. There we go. Right, so bring up your VS Code or whatever editor you're using. I would recommend using an editor with a visual Git extension. I don't generally use those types of things, but it is very useful if you're trying to go through a history like this. You could also just use GitHub. That's probably the simplest option if you don't want to type through this whole thing. And the link to the repository is right here. And then there's also a direct link to the commit list if you want to go through it that way. We're going to be talking about and using a couple of very important crates for doing derive macros, and in fact any procedural macro. The first one is going to be syn, which is a syntax parsing sort of crate, which turns a token stream, which is the way that the code is represented in the Rust first-party API into a more of a syntax tree called derive input. Quote is going to be for taking, it's essentially for building the syntax representation out of just inline code, so you don't have to actually build that as a structure, it makes our lives a lot easier. And then we're also going to be using, Deluxe, which is a attribute parser utility. So for the custom attributes that I had talked about. So does anybody need more time to get to the repository or anything?
I'm just going to ask everybody who is on the live stream, if you're not asking a question, to please ensure your microphone is muted. We're getting some noise coming.
Lightning bolt. So. Well, I realized I used the funky outlet in the kitchen, and then I went to the other side of the kitchen to try a different outlet, and I still didn't get the lightning bolt.
Okay, they both have other switch.
Lucky me, I chose both the wrong ones. Okay. Next
I
time.
hope that's what's wrong.
Probably is.
Did they kept their stove on?
Hey, Bob, could you mute your microphone, please? Bob? Oh, there it goes. Thank you.
Okay, cool. I wasn't sure if I would be able to do that. Okay, let's go back a little bit here. All right, we're gonna switch again. Sorry about this. Share. And then we'll do VS Code. All right, and I am going to, because I unfortunately don't have a dual screen laptop. Why am I sharing Teams? No, I'm sharing VS Code. You guys can see it, right? Okay, cool. There we go. All right. I was going to say, unfortunately, I don't have a dual screen laptop. So I am going to have to read the code off of my phone if I forget. So that's going to be a real fun experience. All right. I'm going to go back up to the top of this thing. Where is it? Yeah, okay. Right. So let's say you have a trait. We're gonna get rid of this main function for now. Well, actually, we'll just move it. We don't need to get rid of it. We'll get rid of this. And we're going to have a trait here. So we'll do trait identify. And this is going to be like extremely primitive reflection. What we're going to do is we're going to use a function, and you could use a const here and it would make way more sense. I'm using a function just because it's more common to use functions in traits, so people are going to be more familiar with it, but we're going to do function type name, I think was the one I gave it. So type name, and then we'll take the self parameter, which means you're accessing the object which this is called on, and we're going to return a static string, which means that it's basically a string literal that's built into the type. Now, inside of here, we're not going to put anything yet because this is not a provided implementation. So we're actually going to leave that body blank, or actually remove the body and just give it a semicolon. And then we're going to create two types, and then I'm going to check what we got here. So we got, yeah, foo type and bar type. I'm going to move this over a little bit and put my phone right here. Wow, that was a great idea. All right, we're going to create struct foo type and struct bar type. And, you know, they could have stuff in them. You could give them fields. I'm not giving them fields because they don't really need anything for this example. But we're going to try and use the function from identify, the type name function on foo type and bar type. And we're going to see that does not work, but it's important to see why. So we'll basically instantiate a foo type variable, and then we'll do another one for the bar type. And they obviously don't have any inner data, so you don't have to give them anything other than just, you know, the type name. And then we're going to print basically the type name of both of them. Oh, I didn't say type ID. I said type name. It makes sense that the IntelliSense is not working here because they don't actually implement that trait. All right. Now, when we hit save, this is not going to work. And the reason this is not going to work is because, as you can see, these do not actually implement the trait that we're trying to refer to here. So we're going to need to implement that trait. And for these, it's going to be pretty simple. Really, all I want is just a string literal with the name of the type. So we're going to just add that in here. So we'll do impl identify for foo type. And we're going to give it that type name. You can hit tab to autocomplete it. And we'll give it the actual string literal we're going to be using here. So foo type. And then we'll copy this and use that for bar type. And then give this a different thing. Right. So if you go into your terminal and you do cargo run, you'll expect it to print out foo type and bar type. And that's great. It's wonderful. But you know, why would you write 5 lines of code when you can write 100 lines of code to write 5 lines of code for you? So we're going to get rid of this. It's terrible. It's garbage. And we're going to create a separate crate. And the reason we're going to create a separate crate is because, and this is what I was kind of talking about when I said that the tooling around this is a little bit janky. We have to create a separate crate for our procedural macros because, if I can get my microphone to work, because the procedural macros have to run from within a separate crate because they run before your code actually compiles. So we're going to actually create that by doing cargo new, and we need to specify that it is a library and not a binary. And we'll give it the name my macros. This history is going to spoil everything. But I would rather not clear my entire command history, so we're going to leave it. And then we're going to add that as a dependency, and you could do that directly in the cargo.toml. But I'm going to do it with a command to make it a little bit more repeatable. We're going to do cargo add my macros and then give it a path to the dependency instead of assuming that it is a crate on crates.io. I don't think that we could get my macros as a crate name. Maybe we could squat on it or something. All right, and then you'll see it pops up here with that actual dependency declaration. So great, we have that dependency. We still can't run our code because we've deleted those implementations. So let's actually make this macro. So the first thing we're going to need to do is a little special piece of wizardry, which turns this into a proc macro crate. Unfortunately, there is no command for generating this, so I wasn't able to make it as repeatable as I would have liked. You can't do this through a script very easily. You could certainly do it through a script. It's just a little bit more annoying. But we're going to go into our cargo.toml in the my macros crate, not the main crate here. And we're going to give it this little lib tag, and then we'll give it proc macro equals true. And that will give us access to the procedural macro stuff. So we're going to delete all this garbage. We don't need it. This is all the just default library code as an example. All right. And we're also going to add our dependencies first. So let's go into our my macros project, and we're going to add cargo add sin and cargo add quote. And then we'll give it a second. And we'll go into the cargo.toml again, and you'll notice that we have quote and sin in our dependencies. So that's all good. And then we actually have to import the things we're going to be using. Now, I could do this as we go along, but I think it's probably easier to just do it at the beginning. So I'm going to go into this lib.rs, which is the main module root or crate root of this macros crate. And we're going to write use proc macro TokenStream. This is the basic Rust syntax type that is provided by Rust. The proc macro crate is a built-in or first-party crate, just like standard library is, and it's only accessible within the context of one of those proc macro equals true crates. So we're going to be importing that. We're also going to give it sin derive input and parse macro input. I think I wrote ident in the blog post thing here. That was not intentional. I didn't want to use ident here. And then we're going to be using quote, which is the macro that quote works off of. Any questions so far? All right, looks like we're good. Okay, and then basically a macro takes the form of a function. It takes in a token stream, it spits out a token stream. So we're going to make that function. It has to be public, I think. And then we're going to do derive, identify, and we can give it whatever name we want, but this is just the most kind of easy to understand one. And then we'll give it a token stream as a parameter, and then it has to pass out a token stream as a return value. And we'll just write a to do here. Now, the other thing that you have to do, and this has tripped me up many times, is to annotate this with a little attribute here, and it's going to say proc underscore macro underscore derive, and then in parentheses you're going to give it the name of this macro as referenced in other your consumers basically. So we'll say identify. Now you could give it whatever name you want. Just like I said, the function name is arbitrary. It's just this, which determines how it's going to be imported elsewhere. Okay, now we're going to actually start writing the script that parses the macro, and then we're going to write the bit that actually outputs the code that we want to output. So this is a little bit of I don't know if I would say it's a magic step. It certainly isn't, but it's kind of one of those things you just need to know because unfortunately, like parse macro input is also a macro and isn't super clear in what it does before you understand it. But basically what it does is it takes a token stream and converts it into a derive input, which is a type that is a lot more convenient to work with for syntax operations. So we're going to do that. So we're going to say let derive input, and we're going to use a little bit of special Rust syntax here, where we basically bind the fields of a struct to values rather than, or the values of fields of a struct to variables rather than binding the whole thing. So we're going to do let derive input, and then we're going to do ident, which is the name of the struct that we are implementing on. It would also be the name of an enum or I guess a union if you're putting that derive macro on one of those types. We'll say type name. So that gives us a, oops, what was that? A type name. That gives us a little piece of data that we can use to refer to the name of the type. And then we also have to do the dot syntax to say, the rest of it we're just going to throw out. And then we're going to say parse macro input and then input. All right. And then we'll let, what? Oh, okay. I just got to put a to do here. There we go. All right. So I don't know why Rust format is not working on this, but I'm going to format it manually. All right. So what we have done here is we have taken the type name because that's the only thing we care about right now. We're just trying to get that type name as a string, basically, specifically a string literal. And the identifier is not a string yet, but we will convert it to one. So we're going to do that right now. So we'll say let type name string equal type name, which is that ident, which is a syn type that says an identifier. So it's a name of a variable or a type or something. And then we'll do dot to string. And actually, I think we do have to clone this as well. There we go. All right. Now, we have our type name as an identifier. We have our type name as a string. Now all we need to do is output the implementation that we want. So let's do that. We're going to use this quote macro. So quote and then an exclamation point. And this, instead of using the parentheses, we're going to be using curly braces. And we'll give it a like this body here. And I'm going to write this as if it was just code that I want to write into my program. So we'll write impl identify. Now, I don't have identify imported here because it's not within the scope of my macro crate. It's actually within my main crate, and I can't access it because of circular dependencies and stuff. So if identify was in another place, you would want to fully qualify this with, crate, and then like some path, and then identify, because otherwise you would have to import it. And if you don't, it won't give you a very good error message as to why it didn't work. So we'll say impl, and I'll just say crate identify just to make it a little bit more representative of what you'd usually be doing, even though this is redundant. Crate identify for, and then here's where quote gets a little bit special. The quote macro allows you to take an identifier or a string or any number of other things and turn them directly into Rust syntax. It's kind of, I don't know what you want to call it, like expansion or something like that. But basically what I'm doing here is I'm going to write type name, and that's going to expand into impl identify for name of the struct that we're deriving on. And then we're going to say function type name, and then self, and static string. And then we'll say inside of here, we're going to return a string literal that represents the name of the type. So we'll do type name string. How am I doing on time? Okay, cool. Yeah, I'd probably do another 10 minutes or something, so it should be probably fine. If it gets too long, I'll just skip to the like gotchas portion instead of doing the attributes. Cool. All right. So what this is going to look like is that, oh, hold on. What this is going to look like is you will have your impl identify for, let's say, foo type or bar type, and then within that function here, type name, it's going to interpret that string into a string literal, which is with the quotes. and it's going to say food type or bar type or whatever the name of the struct is. The reason I have to have a type name string version instead of the identifier version of it is because quote interprets this differently. So if I have an ident, it will interpret it as an ident that it needs to paste into the code, whereas if I have a string, it interprets it as a string literal. I could also potentially do this by taking type name and then putting like quotes around it, but that is a little bit iffy in terms of I think you would have to do a special extra macro to do that. So I'm not going to do that. True. That is true. So we're just going to leave it like this because it's how I have it written here, but that was a good point. He said there's a stringify macro which you can use to convert identifiers into, or anything, I think any expression into a string. Now, I'm going to remove this to do so it gives us a correct error message. Now this says quote, and then underneath the quote there's basically just nothing. So it's returning directly what this macro is outputting. And it says mismatch types, proc macro to TokenStream and proc macro TokenStream have similar names, but are actually distinct types. The reason for this is because proc macro as a built-in crate is only accessible within crates that have that proc macro attribute. And because of that, they can't, and because those can't be used as normal libraries and can't just export arbitrary functions and types, any utility crate or library you're using with token streams and other types of proc macro types cannot actually export those types at all because they can't actually use proc macro. So there's a new crate called, or not a new crate, but a separate crate called proc macro 2, which basically just copies everything from proc macro and makes it accessible as a normal Rust library, and then gives you conversions between the standard proc macro types and the proc macro 2 types. So what we're going to have to do is very, very simple here. We just have to add a dot into at the end of our quote. That's something you'll run into in more complex ways, but this is a very basic way to kind of get introduced to that distinction. All right, now that we have that, I'm going to actually go back here and we're going to import our derive. So let's do that. Now remember, we are importing the derive macro and we're not importing the trait. We already have the trait in scope. If we just could use the trait, we would not have to import anything here. But unfortunately, the derive macro is its own thing. And if I wanted to name this the derive macro identify type and this identify trait, they would be different names. In this case, we're using the same name. So we're going to import that, use my macros, and then identify. And then we're going to add that little derive annotation onto these. So we'll say derive identify. And then we're going to have derive identify. Now you'll see this thing that says proc macro library return no proc macros. This is a language server protocol bug. You should reload your editor. Unfortunately, Rust Analyzer is pretty janky at the best of times, and this is not the best of times. As far as metaprogramming goes, it's about as bad as you can get for any sort of IntelliSense type stuff. So you're just going to have to reload your editor if you run into one of these. I would recommend, if you're ever working with these, to reload your editor as a first resort rather than spending 20 minutes to 20 hours diagnosing a issue that is just going to be fixed by rebooting the editor. There's for restarting. Yeah, okay. Yeah, that rebuild proc macros. Yeah, okay. So so basically there is also I've been informed that there's also a specific command for this. So if you want to go into the command palette and do this, that's totally fine. I'm actually going to do this because I don't know if I reload the window if it'll keep me screen sharing, but I usually have my reload button at the ready. I just have it bound to Command R because VS Code needs to be reloaded somewhat often. So let's see if this works. I guess it's not going to. So we're going to try reload. Reload window. All right. I guess I don't have it bound on my on this computer. Okay. Now, let's try our code. Our cargo run. Oh, hold on. We're going to go back into the actual main crate and not the Derive macro crate. We're going to do cargo run. And there you go. You have foo type and bar type. Now, if you want to see what this is actually doing, you can do cargo install, cargo expand. Now I already have it, so it's going to probably not install anything. Or maybe I don't. I guess that was on my other computer. And then we're going to do cargo expand, and it will show you what it actually looks like. Now, there's a lot of kind of random garbage in here because of the print macros, but you can see what the actual output of these Derive macros looks like, and it looks exactly how you'd expect it to look. How's time going? Okay, cool. All right, I'm going to kind of breeze through this last bit because, yes. Yes. So the question is, does it inject the code directly after the struct definition? As far as I'm aware, there is no way to determine, or there's no way to edit where it's going to spit out that code. Generally, struct definition is top level, so you're not going to have any issues with just spitting out right after. And because of the free-form nature of Rust syntax, you won't have any issues with needing to be in scope of a specific thing. So if you wanted to write another inherent implementation for a type, you don't have to be within the context of that type definition like you would be in Java or C#. Yes, yeah. There's other ones that are more complex and will actually replace the code or put it in a different place, but derives will just append the code. So let's see here. So let's say we wanted to add a new thing to this. Let's say we wanted friendly type name. Now, the problem with this is you could kind of make some assumptions about how you would want to name something in a friendly way, right? You could say, well, it's probably just going to be like the name, but in a different case convention, right? Everything's lowercase and has a smiley face at the end, right? But sometimes that won't be the case. And so in the case that you want to be able to change that, you might have to add some extra metadata that you wouldn't have otherwise been able to do in the type system of Rust. So let's add a example attribute here where we say friendly name equals foo type. And then not exactly the standard definition of a friendly name as far as programmers go, but that's what we're going with. Friendly name equals bar type. And this one's going to have an even bigger smile. There we go. All right. Now, if I wanted to print these out, I can do, I'll just copy these and do friendly type name and friendly type name. Now you'll notice that our IntelliSense is auto-completing this, which is kind of weird because they don't implement that function, but they do implement the trait, theoretically, that implements that function. They just haven't properly implemented it. So you'll see in this derive, you'll get this error message, which is actually pretty helpful, saying not all trait items implemented and what it's missing. So we're going to have to go back in and fix that. So I'm not going to belabor the point too much here because we're running out of time, but I'm going to go into lib.rs. We're going to add a, in the proc macros crate, we're going to go back into that, my macros. We're going to add a crate called deluxe, which parses attributes for you. And then we're going to create a little struct that allows it to actually parse the attribute we want here. So let's create that struct. And we'll just call it, what did I call it here? Friendly name attribute, I think. Friendly name attribute. And we'll just do, we're we're going to go back here actually. And I think that we have to do this instead of the equals syntax. It's a little bit weird. I've had inconsistent experiences with Deluxe, and it is no longer maintained, so it's very hard for me to get support on it, but it's fine. It is what it is. All right. And so this is what it's going to parse into. We have to annotate it with some more wonderful little attributes here to tell Deluxe how to actually parse it. And we're going to say on this, where is it? Yes, we're going to do use Deluxe extract attributes, first of all. And then we're going to derive macros within derive macros. How lovely. All right, extract attributes. And then we're going to, and so that's kind of like a parser trait. And then we'll do Deluxe attributes friendly, attributes, and then give it the name of the actual attribute that it's going to be. All right, now let's parse it. So we have to do this a little differently this time because we actually have to get the derive input in full. So we're going to switch this to, instead of just binding the type name, I'm going to make it let input derive input equal parse macro input. So this is shadowing or replacing the variable that was that token stream and turning it into a derive input, which is considerably more useful. We'll have to make it mutable for reasons that will become a little clearer in a moment. And we're also going to need to bind that type name like we did before. So let's grab that. So we'll say let type name equal type input dot ident dot clone. And then we'll do, this should fix itself. There we go. Okay. Now we need to get that friendly name. So we'll do let friendly name string equal, I think it's, I have to do friendly, I need to do some destructuring here. So friendly name attribute, and then friendly name string. So we're binding it within that, that tuple struct. And then we'll do deluxe extract attributes, deluxe extract attributes, mute input. And then we actually have to unwrap that because it returns a error or a result type. And we're not going to handle that right now. So we're going to add our new function to our quote. Function friendly type name self static string. Again, I'm very aware that this should have been a const, but that's how I wrote it. So all right, we're going to do friendly name string. And now let's see how it works. I have to reload it again. And hopefully this will work. Oh, no, there's one more thing I forgot this genuinely right now, but this is another gotcha. So we're going to remove this actually, but you need to add attributes into your proc macro derive declaration. So we have attributes friendly name, and that would make it work. So now it knows to recognize this as a member of the trait identifier, the derive macro identify. All right, let's try running it. There we go. I have a little list of gotchas, but I think I basically covered all of them. It's stuff like, proc macro 2 versus proc macro, and forgetting to write those little attributes on your derive macros and such. But yeah, does anybody have any questions? Yes. All of the what? Destructuring. Yeah, so it's not required. In Rust, you can just bind the full struct, and then you can just reference a field. But especially with the tuple structs, I really don't like using .0 or .1. It's really kind of obtuse. So instead, it's better if you just have like a couple values. You can destructure it when you bind it. The question was, is it necessary to destructure these using the binding statement, basically? Anything else? Yeah. Yeah.
Where would that generally for someone else to use. So that would have to be in one crate, then the Derive would have to be somewhere else in a different crate.
Yeah. So the question is, where do your Derive macros actually live if you're trying to use them on more than just one crate? And the answer is they can work just like library crates. However, generally I think when you are working with a project which includes Derive macros as a feature, you will have to have I think you would have to have a cargo workspace, which is a workspace with it's a project with multiple crates built into it, and then you can reference those and basically depend on those, and you can re-export them under different names for the consumers of your crate. You can also have it as a standalone crate if you want. Anything else? Yeah. There's not a lot. So the question is like, are you asking like, are there any resources on procedural macros or how to build them? Oh, yeah. Are there conventions around macros and particularly regarding how to use them as crates and libraries and dependencies and stuff? The answer is the conventions are mostly just enforced by the system itself. There's not a lot of conventions because there's not a lot of people writing these, as evidenced by the fact there's not a lot of learning material on them.
You'll see a lot of -derive crates. So for crate foo, like this error, you'll see like a -derive of for the macro definition crate name. That's one of the patterns you'll often see. So if you're looking for how to write these and you're looking at crates that are actually doing it, often look for the Derive crate. Yeah, the name of the crate -derive is a common pattern you'll see.
Yep.
Yeah.
I was just going to say that one time I decided to do proc macros instead of having levels, the one that defines like your print and then the macro one. I decided to make 3, and the third one only knew about the proc 2 stuff. And that way I could actually single step and debug it because it didn't go all the way to the official proc thing.
So
Very thin.
You have like layers of basically code that's referenced outside of the context of the like official proc macro crate. Is that what I'm?
Talked about it.
Yes.
Have a helper library. I put 9% of what I was doing in my own helper library.
Yes.
Because then I could actually debug it and just run regular unit tests on it. It was like nice. The one little layer that turned that into an official macro just had to work because it was very hard to debug.
So what he's pointing out is that it's very difficult to debug Derive macros in a lot of cases because of the inherent limitations of the type of crate that works with a procedural macro. So it might be helpful to refactor those things out of that crate and put them into helper crates and then be able to debug those. I've done that within my crate, not outside of the crate, but I usually take that Derive macro function and then pass it through to a lower level function that can be declared outside of the direct module, like the top level module that it's in, because you can't declare those outside of the top level crate module. All right. That should be all. Yeah.
Thank you. That was a great talk.